Today's lesson is on solving one-step and two-step equations, linear equations. So how do we start this? Well, one-step equations means it should take you one step to solve this equation. Okay? So what has happened here was you had some mystery amount that when you added 12 to it, you got 10. So in order for us to get back to this mystery letter, also known as a variable, we need to undo this equation. Okay? And so what's happening here is one side is kind of whittling down to the letter, while the other side is actually doing a lot of the math behind it. Right? And that's why we're doing the same thing to both sides. We're trying to balance the equation. So one side, like I said, one side is getting back to the letter, and the other side is doing all the actual numerical figuring out. All right, so if you added 12 to m to get 10, you want to undo that. So you're going to subtract. Okay, you're going to subtract 12. All right, but again, all that's going to do, if I just do it to one side, it's going to give me m equals. And if I don't do something to the other side, I'm going to put down here 10. M equals 10. If I were to put 10 back in here, 10 plus 12 is not 10. So whatever I do to one side of the equation, I have to do the other, so the other side has a chance to figure out the number part of this, or what the answer is going to be. So if I am dropping the left side by 12 by subtracting, I have to drop the right side by 12 as well to keep it what's called balanced. You're trying to balance the equation. You need to keep everything balanced by doing the same thing to both sides. Sort of like on a teeter-totter. You ever been on a teeter-totter before? If the weight's the same, it's actually not really a lot of fun to ride because you both weigh the same. You both would hover in the air and no one go anywhere. But someone's always slightly heavier. So then you can push off and have some fun, right? Well, if you're balancing it, you're trying to make it so that instead of your pen kind of going both things like sort of like a teeter-totter, it's keeping it balanced like straight. All right, so whatever I do one side, I do the other. So 10 minus 12 is negative 2. When you take away more than you have, you're going to the negatives. Now if I wanted to check that, I could put the negative 2 back in here and say, what is negative 2 plus 12? If in my calculator I put in negative 2 plus 12, I am going to get 10. So I know that that's right. Okay, all right, so let's do number 2. Again, I'm trying to get the letter all by itself, and that's what the mystery is. I know everything else about this equation except what is g. So I'm going to undo this equation. So since this says plus 9 or minus 9, I'm going to add 9. And again, whatever I do to one side, I do the other. And I put a little line here. If you're really sloppy at your math, if you put a line down the middle, just make sure you put the same markings on both sides of your line. And then that'll help you remember to do that. Now, if I took away 9 and then I added 9, I'd be back to g again. So these kind of wipe each other out if you want to think of it that way. In fact, if you wanted to and put a light line through there, you can to remind yourself that they no longer exist, right? Because you've knocked them out. Negative 2 plus 9 is 7. Okay? So again, if I were to put in the calculator 7 minus 9, I am going to get a negative 2. So that's how I know if I'm right. Okay, number 3. Number 3 says negative 7y equals negative 91. Well, again, I'm trying to get the variable by itself. This time, it's not attached by addition. It's not attached by subtraction. It's attached by multiplication, because this is actually negative 7 times y equals negative 91. So in order to get rid of multiplication, I have to do its opposite, which is divide. So I'm going to divide by negative 7. Remember, whatever I do to one side, I have to do the other. Okay, negative 7 divided by negative 7. Any number over itself. Any number over itself is always 1. So this is y, if 1y if you want to. And then negative 91 divided by 7 is, oh my lord, 13? 13. And a negative over a negative is a positive. Okay, and again, if I want to check my work, I would just put in the calculator 13 times negative 7 and see if I get negative 91. Right, so that's the solution to that one. Okay, last type. Again, we've done add, subtract, multiply. Now we got a division problem. A over 9 means A divided by 9. In order to get rid of divided by 9, I need to multiply by 9. And I'm going to do the same thing to both sides. Again, there's my equation. 9A divided by 9. 9 over 9 is still 1. This is A. Again, if you want to put 1A, you can. If you want to put 1Y, you can. But it's understood that if you have a letter all by itself, it's a 1. Okay? And then negative 4 times 9 is negative 36. So, there's your solution. A is equal to negative 36. All right. Now, we go to do these types of questions. These types of questions, it says in order to get rid of the fraction, we have to multiply by what's called the reciprocal. The reciprocal. That's your fraction flipped over. Okay? So the idea behind that is, if you think about it, think about how I got rid of this guy and think about how I got rid of this guy. Okay? This is a combination of both of them. This actually, if I cover this up, this looks like it says 2x equals 10, doesn't it? And if I took away this 2, this would look like almost like x divided by 3. If I scooted that x up a little bit, it'd be x divided by 3. So this is a multiplication problem and a division problem all at once. So if I asked you, how would you get rid of times x? Wouldn't you divide by, or excuse me, times 2 times x? You would do it by dividing by 2, right? Now, how do I get rid of dividing by 3? I multiply by 3. And lo and behold, I've just written the reciprocal of this number right here. And again, whatever I do the one side, I have to do the other. Now, if you don't remember your fractions, anytime you get a number over nothing, you put it over 1. So that you have a thing, and then you just multiply straight across. So this gives me 15 over 2, which is, or excuse me, 30, I'm ahead of myself. 30 over 2, which is 15. So x is 15. And again, if I typed in 2/3 times 15, I would get 10 in my calculator. All right, so same idea here. Forget about the reciprocal. Just think about what I did with multiplication and division. If this number is on the top, this number needs to be on the bottom. If this number is on the bottom, this number needs to be on the top. And then just write it on the other side. Again, when a number is by itself, write it over 1. W equals, because remember, all this works out to is 1 over 1, right? 9 times 4 is 36. 4 times 9 is 36. 36 over 36 is just 1, which is your goal. 1W equals, and then I do this work, which comes out to be negative 18 when I'm done. You can use a calculator for that. If you want, just type it in and it will give you negative 18. Use decimals if you need to. All right, I think you get the idea. If there's a sign in there, like these two, all you have to do is make sure that you carry the sign along with it. So this, again, this is going to be 5 over 6, and you'll have to put a minus sign in there. I'll squeeze a minus sign in there. It's not much room. I'll write it down here. Okay, I don't mean to put that parenthesis there, but oh well. Scratch that out. Okay, so see how the 5 and the 5 get canceled, and then the 6 and the 6 gets canceled. One on the top, one's on the bottom. 6 over 6, 5 over 5. That gives you 1 over 1, and a negative makes a positive. So whatever I did on one side, do the other. Again, put a 1 over there if you want. So this is going to give me, if you multiply straight across, it's going to give me negative 60 over 6, which is negative 10. Now this one, again, you see 1 over 2, just put 2 over 1. I mean, so it's not too bad. All right, 2 steps means it takes 2 steps to do these equations. Okay, so what your goal is to get to the letter. So your goal is to get to this letter right here. Okay, in order to do that, you have to undo everything you see. So the idea here is we're going to do, like, remember when you learned PEMDAS or the order of operations? Okay, what you're going to do is, because we're trying to undo everything, is you're kind of going to go in that direction. So you're going to do any adding, subtracting, undoing, and then multiplying and dividing. Remember, we're undoing. We're kind of unraveling the steps that have already been made. Okay? All right, so in this particular problem, I got to do any adding or subtracting first. So see how I have added 8. Now I'm going to subtract 8. And again, whatever you do one side, do the other. Again, make a line if you're sloppy. Math writer. This comes out. I'm going to cross this out kind of briefly so you can see that those knock each other out. Now I have 6x equals 42. Now that problem is looking like this one. Okay. So this is a multiplication problem, so I'm going to use division to get rid of it. So once I do that, 42 divided by 6 is 7. And I'm done. Okay, so the two-steppers really aren't too bad. It's just that you're doing 2 steps. So you took 2 steps to get to the answer, where all of these only took 1 step, 1 step, 1 step, 1 step to get through the whole thing. All right, so I'm going to do some tricky ones. Let's do number 12. Well, we'll do 10, and then we'll do we'll do all 4 of them. Why not? Okay, so this next one, we're going to add 5, because again, we're doing any adding or subtracting first. That's out of here. Okay, now I'm left with 2n equals 16. And then, because I have 2 times, I divide. And you're going to find in math, a lot of times you're doing division as the last step in algebra. But not guaranteed, but most of the time you are. All right, next one. Okay, again, don't let this confuse you. Having them on the kind of quote-unquote wrong sides, because I have the variables. See how the variables seem to always be on the left. Well, this one's on the right. No big deal. Solve the same way. Just focus on the letter. Okay, so you want k by itself. So that means I get rid of my 9. So that's what? 4 equals negative 4k. And then, because this is a multiplication, I'm going to divide. And k is negative 1. Now, you could put k is equal to negative 1. You can turn it around if you want. Remember, we can do that because of the symmetric property, which means if a equals b, then b equals a. So I'm allowed to switch it, flip it around, and it's still the same answer. All right, number 12 is one that gets students a lot. And the reason being is this minus sign is attached to this 3, not to this 7. Because if I added 7, because I saw this minus sign and I added 7, I would make this worse. If I added 7, I would make this 14. I need to subtract 7. So the minus sign is really on the 3, not on the 7 in the original problem. So what's that? 27. Okay, so now it looks like that. Then divide by negative 3. Divide by negative 3. Y is equal to negative 9. And you're done. Okay. Okay, the next problem we're going to do is 14. Okay, so 14, I can tell what's going on. I have an addition problem and I have a division problem. So I have addition and division. So I've got to use subtraction and multiplication to get rid of it. That's what I got to do. All right, remember that we're doing PEMDAS in reverse, so I've got to do subtraction first. Subtract, so this is going to give me 3 equals c over negative 5, or divided by negative 5. In order to get rid of divided bys, we multiply. Okay, so that's going to give me negative 15, because the signs are different. And again, these are dropping out. That's the whole idea. And then c is negative 15. Here's the answer. Okay, number 17. Now, again, my goal is to get to the letter P. I want to get here, so I have to get rid of everything else away from it. Again, another good way to remember it is the things that are the furthest away from P are what I want to try to get rid of, that are on the same side of the equation. So since this negative 10 is way over here and the P is here, I want to get rid of this first. Right? How do I get rid of negative 10? If I subtract 10, that's going to actually make it worse. So if you haven't picked up on it, what you should be seeing every time when you're trying to knock a step out, you should always see a minus and a plus everywhere. Look, plus, minus. So you should always see them knocking each other out. So look, see? Minus, plus, plus, minus, plus, minus, plus, minus. Okay, so they knock each other. Let's see if I got over here. Minus, plus, plus, minus. They're always knocking each other out. So you should always see the different signs when you're doing adding or subtracting. All right. Okay, so let's go. So we added 10 to both sides, and now I have 7/4 P equals it's negative 28. Now remember my trick to doing this. Again, you can remember the reciprocal idea, but you can also remember I need to knock each one of these things out. So if I put a 4 here, that knocks out that 4, and I have a 7 here, I'll put a 7 there. Now I'm going to do the same thing to the other side. 4/7. Again, over 1, these knock out. I just have 1P equals, and then I get this answer, which looks like it's going to be, let's see, negative 16. Negative 16. You can put that in Desmos, or you can use your phone. You can type 4 divided by 7 times negative 28, and it'll give you that. All right. Okay, last one I wanted to do was this one, because again, it looks like it's out of order. It looks like it's on the wrong, quote unquote, the wrong side. There's lots of things going on here. All right, so the first thing I want to do is get rid of what? I want to get rid of the 9. Okay, again, here's the variable. I want the furthest thing away from the x on this side is this 9. So I got to get rid of that first. Remember that that minus sign is attached to the half. It's not attached to the 9. The 9 is not being subtracted. The half x is. So I got to subtract 9 to get rid of it. Do the same thing on both sides. 6 equals, and again, you got rid of this, but this minus sign you haven't used yet, so you have to bring it down. If you don't use it, you have to bring it down. Okay? All right, now I have to get rid of this negative 1/2. So again, I got the reciprocal idea going on again. All right, negative 1/2 turns to negative 2/1. Remember, the 2 knocks the 2 out, the 1 knocks the 1 out. And again, as long as you have one sign, it doesn't matter. Because again, if I were to multiply straight across, this would be positive 2, and this would be positive 2. 2/2 is 1. Right? Whenever I do to one side, I do the other. So my answer is x equals negative 12. All right, so we have these last two that I have to do in a couple minutes that I have. And all thing you have to worry about with this one is you have this x plus 7 divided by 8. And the issue here is both of these things are being divided by 8. So what you're going to have to do first is you have to get rid of this 8 first. So this is a special time where I can't do adding and subtracting first because I've got this all being divided by 8. So we can't do that. So let me bring this down so I have some room to work. So what I'm going to do is I need to get rid of that 8. And this is divided by 8. So I'm going to multiply it by 8. And what that allows me to do is kind of free up the top of that fraction. So now I have this. Okay, because remember, these are now gone. And now I just get rid of it by subtraction. And there's my answer. So this is an instance where you have a special type where you can't do your subtraction or your addition first because it's all being tied into division. And this is the only type of problem that you can't follow the rules of undoing where you do addition and subtraction first and multiply and divide second. you have to do that division first, because this minus 5 is actually not minus 5, it's minus 5 divided by negative 2. So it's uglier. So what we need to do is we need to get rid of the number underneath the division. This is a division, remember, so I got to multiply by negative 2. Multiply by negative 2 to get rid of these 2's. So now I have n minus 5 equals, what's that? Negative and negative is positive, 14, then add 5. So in these instances, my adding or subtracting is being done second, but only because of these special cases. So hopefully this all helped you.